In the run through of the mock, which was November 2018, Edexcel paper 3. So on to question 6. Right-angled triangle. Well, they told me that in the question. So straight away I'm going to get rid of that bit of information. AC is 14. That is all on the diagram. So now size of angle B, then the size of angle A is 3:2. So hang on. This totals 5 parts. I wonder if I can work out what these angles are before even thinking about the rest of the question. So there's 5 parts, and I've used up 90 degrees already of the triangle. So there must be 90 left to make up 180. So I'm going to do 90 shared by 5, which gives me 18. So if I times these two by 18, write that a little bit more neatly for you, times 18, I should get the amounts. So let's just do that on our calculators. 3 times 18 is equal to 54, and 2 times 18 is equal to 36. Okay, so assuming, so that's B to A. A is the smaller one, that's 36 degrees, and that is 54 degrees. So I don't have to hold any of that in my head, it's all on the diagram now. So I don't actually need any of this either. I might use it to check later on. So it says work out the size of angle A, of length AB. So that is what I need to work out, that length there. And I'm going to give my answer to correct to 3 significant figures again. Okay, so I'm not going to worry too much about that. I'm going to answer the question. Right-angled triangles should trigger you to think about Pythagoras or trigonometry. In this case, I don't have enough lengths for Pythagoras, the easiest one, so I'm going to use trigonometry. So I'm going to write on, I'm going to relate them to my 36, my angle of 36. You have a choice, you could do either. So this would be the opposite. I'm not interested in that one. This would be the hypotenuse, because it's opposite the right angle and it's the longest side. And this side would be the adjacent. So I know on this one I need to be looking at one with one of my ratios, and my ratios are on my calculator, sine, cos and tan, but I'm going to use the word SOHCAHTOA. SOHCAHTOA. And I've got, this time I want the hypotenuse and the adjacent. Hypotenuse and adjacent, the only one that links those two is cos. So I'm doing cos of an angle is equal to the A over the H. They always come as a fraction, these two bits. So you get used to writing them in that way. So this is cos of 36 degrees is equal to the adjacent, which was 14, divided by the hypotenuse. So let's rearrange this a little bit. Remember, be careful when you do this. So it's divide by h, so I've got to do the opposite, times h. So that gives me h cos 36 degrees. The h cannot go with the angle, because it's the length. Is equal to 14, and then I'm going to get rid of my cos 36. I know my calculator can work out cos 36 by dividing by cos 36 degrees, so h is equal to 14 cos of 36 degrees, and let's put that in my calculator. So we've got 14 cos 36 degrees equals 11.326. And I'm going to round that again. Let's keep it as roughly the same amount. I've got 1, 2, 3 significant figures. I'm going to cut it off there, but the 2 can't see over the wall, so that would be 11.3 to 3 significant figures. Probably should be it's almost equal to there. And there we go. Where are my marks? I honestly think that there are marks up for grabs here. So part number 1 is for finding out one of those angles. Process number 1. Process number 2 is for getting a correct trigonometry equation. Process number 3 is for knowing to getting down to that step where you've got 14 times cos 36, and then of course there's an accuracy mark on the end. It's not a disguised question. The complication, I guess, is the ratio. Okay, on to the next one. This is definitely not a disguised question, so it's going to be a nice one for us. Table gives the information about the speeds of 70 cars. There's the speeds, and they're in categories. And there's the frequency, so 14 cars were going between 0 and 10 degrees. I don't know how fast they were going, but they were in that category there somewhere. Draw a frequency polygon. So frequency polygons are straight-sided shapes. But the trouble is, I know I need to plot 14, but I don't know where. So in this case, in frequency polygons, you always go halfway. So 5, 15, 25, and 35. Because I don't know where to go in the category, it makes sense to go to the middle. So 5 up to 14. And then I'm going to go 15, needs to go up to 18. 25 goes up to 26. Sorry, 25 goes up to 26. Again, use a pencil so that if you make an error it doesn't matter. And then the last one. Now, because it's a frequency polygon is a straight-sided shape, so I'm going to join it up with completely straight lines, unlike the scatter diagram that I did earlier. There we go. 1 mark for getting halfway between process number 1, and 1 mark for having straight sides. Just a simple point, don't join it to 0 because there's no data down here, and don't join it up to the floor there or join underneath. Even though it's a polygon, it's an open polygon, we call this, so don't close it because you'll drop a mark. Next question. Diagram shows a solid metal cuboid. The area of the 3 faces are marked on the diagram. The lengths are in centimetres of the edges of the cuboid are whole numbers. So I haven't got the lengths here. So before I even look at the rest of the question, I'm going to try and think about what the lengths could be. And I'm going to think 27, well that's 27 is 3 times 9, isn't it? If that is 3 times 9, I might put the 3 here because 15 is 3 times 5. So I'm going to say that edge is 3 and that edge is 5. So this edge would be 9, and 9 times 5 is 45. So already I've got the edges. So I actually don't need to look at the rest of this top bit anymore. I've used all this bit. I could almost tick it. The metal cuboid is melted and made into cubes. Each cube has sides 2.5. Work out the greatest number of cubes that can be made. So they're melted. They don't have to be fit in, they have to be melted. So let's work out the volume of the big cube then. So that would be the volume of the cuboid, up to you how you say it. I've drawn it, and would be the length times the width times the depth. 9 times 5 times 3. My calculator will do that for me, just to make sure I'm getting it right. 9 times 5 times 3. 135. And that is in centimetres cubed. So now I'm going to need to find out how many fit in. So I need to share it into 2.5s. So, sorry, not into 2.5s. The volume of the cube is going to be 2.5 times 2.5 times 2.5. 2.5 cubed. So I've got now I'm going to cube it, because that means 2.5 times 2.5 times 2.5 gives me 15.625. Now I'm going to divide them, so I'm going to do 135 divide by 15.625. 135 divide by my previous answer. Gives me 8 point something, so equals 8.64. So what is the greatest number of cubes that can be made? It's not 8.64 cubes, it's going to be, I can't make 9, I can only make 8 cubes. Let's tell you where the marks are for that one. So they are for a correct start to the process for this idea of getting the whole numbers for the edges. Get a mark for multiplying those. That's process number 2. And then you get a mark for also for doing this one. And then you get another mark for doing your division. Process 3, process 4, and then you get a mark for getting accuracy mark for getting the 8 cubes, knowing that 8.64 isn't a number of cubes. Okay, question 9. Let's see how quickly we can get through this. So this is expand and simplify. This looks like a complicated question, so I'm going to carry on this process I've been doing for nearly all the questions here. I'm going to do the first bit first. I'm going to expand x minus 2 and 2x plus 3. I can use my grid as I always do. So I've now got 2x squared, 3 minus 4 is minus 1, so I've got minus x, and then I've got minus 6 as well. So, and that's going to be times by the last bit, which is x plus 1. We'll use another grid, x and plus 1, and I'm going to times that by 2x squared minus x and minus 6. It's going to give me 2x cubed minus x squared so the final answer is 2x cubed (2 minus 1) finished. Okay, next question. Quite a nice one. So I've got something, a number of y's times another number of y's and divided by y over 2. So I've got to, effectively, we've got 4 plus n, take away 2, gives me minus 3. because if we look here, you add the powers on the top, so 4 plus n, and then you take away the power from the bottom, so take away 2. So I've got this equation to look at, so I'm going to tidy this bit up first. 4 take away 2 is 2, so I've got n plus 2 is equal to minus 3. And if I take away my 2, both sides, n is equal to minus 5. There's a mark for writing this bit at least, process 1, and then a mark for the answer. Okay, last part here, solve this to 3 significant figures. That's our trigger, 3 significant figures. To remember, we're going to be using x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm sure you appreciate my singing, so let's put all that in. So it's going to be minus whatever b is, which is negative 4 here, plus or minus, so I'm going to do both sums. Edit my line. I've got minus 4 squared, because that's a, b and c. Then I've got take away 4, lots of a, which is 5, and c is negative 3. And that's all over 2 lots of 2a, which is 5. So type that into my calculator. So negative, being careful to use that negative button again, negative brackets negative 4, close brackets. I'm going to do the plus one first here. Plus square root of negative 4 take away 4 brackets, and let's just double check that is a 5, it is 5 brackets negative 3 brackets, and this is all going over actually, isn't it? So let's see if I can get my fractions button to work. So let's step over, just see if I can get it working. Oh, there we go. Right, I'm going to start again. So, fractions button first, same process again. Just type it in, press your equals, and you get 1.2717, and then it says round it to 3 significant figures, so I'm going to be cutting it off just here. So that's going to be roughly be equal to 1.27, and then I'm going to do the same for the plus, but the easiest way to do it is just to go back and edit the line.